Okay, so flight controllers. We're going to focus on the CC3D OpenPilot software. So the CC3D, if you look at the slides from the past workshop, is about a $15 flight controller. It has all the capabilities of a NAS32 in a cheaper package, and it's kind of better in every way. So that's why we're focusing on the software that it runs. We're going to look at the hardware of the flight controller overview. We're going to look at the calibration methods and what screenshots you're going to be looking for when you're calibrating components. We're going to be looking at the outputs, what you expect to see once everything is calibrated. And then we're going to be looking at receivers and how to bind a receiver. You want to hit the next one. So, Levi, you want to take this? You got the experience with OpenPilot.
All right. So basically, we're just gonna walk you through some screenshots of OpenPilot, and so basically, yeah, this is the open page. When you open the program, it'll take you straight here, and you have a couple different options. First thing down here is the tabs flight data. That's where you're actually gonna get like everything as far as like looking at how level it is and configuration for tuning and setup, but later we'll show you the Express Wizard, and right now go a little bit more into the next. Hardware, this page, not really much to explain here. I just mostly share the screenshot because it's an example of the settings that works. I don't know exactly how all this stuff works, but most important part is the baud rate right there, 57600. Might run at that number a lot. You always, that's what everything's going to be set to. We'll run at that a lot more later though.
Yeah, that's a important number to remember if you're having trouble connecting your ground control to your flight controller. The first thing to check is see if your baud rate is correct, because some defaults will be about like 9,600 or upwards of 115,000. And if it's off, it might not connect.
All right, so first page on, a little bit off actually, it's supposed to be vehicle. Basically this page is just selecting, multi-rotor. It's got the different configurations. If you want to do an octocopter, this is where you would select it, and then of course it's just showing your different motors when you set it up. A few things that I want to make note of, if you look at like the fixed wing, with the CC3D you actually can do plane setups. It's got all that, and then ground, everything, like it's got a whole lot that you want, and then custom, just setting up servos maybe if you want to do like a robotic arm or something. But next page, input again. Let's see, RC input. This page right here in particular is where you're going to spend a lot of time. This is where you're going to calibrate your transmitter. We're going to walk through a lot with this at the end, but main thing you're going to want is looking at whether your controller is PWM or PPM, whether you've got the one cable or you're an individual cable for each channel. Of course, as you can see, I've got each individual channel for my transmitter selected. After that, mostly just the calibration and then a little fine tuning, which we'll cover more later.
Yeah, we'll go also into PPM and PWM, what they mean, what they're used for, so that's not as much of a frost mystery as it sounds.
Input 3. Okay, this part right here, primarily just your arming setting. This thing will reset itself a lot, so if you find yourself not being able to start the quad, just come back here and make sure your arm setting's right, because I find that all the time. Every time you change a setting, this will reset, which is always defaulted to just off. So, yeah, standard yaw right, you just throttle down, bottom to the right, and gets you going.
And arming, if you didn't know, is giving your flight controller the command that you can actually turn the motors on. If you're not armed, the motors will never spin up. So you always arm when you're ready to fly, and don't go near and put your hands by the motors when it's armed, because sometimes flight controls can be finicky and spin them up. So just pro tip.
We got output already.
Output?
These got a little bit now.
Okay.
Output. This part primarily, These little dials right here are set to tell the flight controller exactly when the motor kicks on. That little setting down there is when the prop starts to actually spin. So that's all you really need to do on that page. And then that up here, the update, I can't really read it, what it says, but that refresh rate, I think it says 490 hertz. That's the one that you want to make sure that it's at least 400 for your flight controller. If it's down at 50, then you're not going to be flying anywhere. That's for the speed controller that we covered a couple weeks back or whatever.
Yeah.
And then attitude. This page, not much to say here actually. This is something we were talking about earlier. You can actually, I've never used it, but you can tell the craft, like if it's in a different orientation, like the controller itself.
Yeah.
And then
So
calibration.
today we were flying the big quad, and what was happening is when you take all your hands off the sticks, and it should stay at level, it was going one direction. So we were wondering if we calibrate the compass to be a little offset that direction, that it'll stay level. So if you have those issues, you can maybe go into the attitude and adjust those parameters to kind of fine tune where your flight pattern.
All right, and stabilization. This primarily is just your main page for, of course, tuning, which is actually the other part you're going to spend most of your time at, which I'm sure we're going to have another workshop on this one, right? So we won't go too much into that, but one thing we didn't cover earlier, you have switches back in your settings for your input, and each one of these settings bank is for each of your different flight modes, and that's pretty much it after we get to the
So once you get your flight controller, it's not going to really be a plug in and play. You're going to have to get all of the components wired up and then tune everything so that the flight controller knows what's going on. So a lot of that is going to be the PID tuning, the compass tuning, the accelerometer tuning. So making sure it knows where level is, what stable it looks like, how to get back to stable. So we're going to probably week 8 or 9 go into another workshop on how to do all of those specific things.
So before we move on, do we want to just touch on these guys before we?
Sure.
We didn't cover them this time, but pretty much this is your gimbal setting. You can actually set up a gimbal with it, which is, I don't know, I'm sure you guys probably heard like the camera stabilization. And can actually do that transmitter PID. I'm not actually sure what that one is, but not stuff that we're gonna really mess around with at this point.
So, you have your flight controller, you have it set up, but one of the main things Levi said, one of the main pages you're going to be on is going to be that radio transmitter page. So in order to calibrate anything, you need your actual transmitter. So the two ones I'd suggest, mainly because of price, are either the Turnigy 9XR or the Spectrum DX5. We recommend these because these are going to cost you below $100. They're going to give you effective. They're going to give you reliable means of flying your quadcopter, and some of the other ones that, like the FR Sky that we run on that one, go upwards of like $250, and that's probably going to be more than your quadcopter costs in and of itself. So we wouldn't want you going that route. The differences between them: the Turnigy costs a little more, but it gives you a lot more access to different channels, which you can use for servo inputs, other I/O, and it also has LCD screen. However, there's a lot going on. There's like a million switches on it, and sometimes a million switches isn't good. Whereas the DX5 costs less. You can get it at Trump's Hobbies for $50, so you don't even have to wait for shipping or anything, and it's simple and effective. It does what you need it to do. There's nothing confusing about it. You're just going to be able to turn it on and get going. So the transmitter transmits a signal, but then you need a receiver to receive the signal. Funny how that works. These are a few receivers that I'd suggest getting. They're inexpensive. They cost usually below $20. They have between 6 and 8 channels. That is, you'd probably want to pair that with the receiver, the transmitter that you're getting. For So positives and negatives to look at. The FR Sky has a very high interference resistance, meaning that you're probably not going to lose connection ever. However, the Spectrum has a low interference resistance, so if you're flying in high traffic areas, you might lose your connection with your receiver, which is bad. So those are some things to look into when you're looking for your receiver. These are typical setups for the 1 through 8 ports. Roll, pitch, throttle, yaw, and then the mode switch, which will change you between stabilize, loiter, auto, acro, tons of different modes that we will go into in probably the tuning workshop. So when you get your receiver, this is a good slide to refresh yourself on as to which pin goes where. Go to the next slide. So we mentioned PWM and PPM signals. These are what the ESCs are expecting to run the motors. If you hook up an O-scope to the signal wire and the signal and ground, you'll see a waveform of this likeness, and that you can tell that you're getting a signal from that. The difference between them is mainly PWM can go to all ESCs. However, some autopilot systems, like the Pixhawk, require PPM signal. So if you're going to go for a more expensive flight controller, if you're going for autopilot waypoint following, then you may have to go towards a PPM. And a PPM signal will go through one wire, PWM will go through the multiple wires. That's a good way of knowing what's going on. Finally, binding. Are we going to do a demo of this? Or?
We can. Mine does not have the clip of the plug, so if you want to.
Okay, so we probably won't go through a demo of this right now, but these are the main steps of how to bind a receiver to a transmitter. It's very simple, however, it can seem a little overwhelming at first, I guess. So what you'll do is you'll first insert that sort of bind plug. It'll look something like that. All it is a wire that connects the ground to the signal. Some receivers are a little different, but don't make sure it goes ground to signal. Then you'll power on the receiver. Usually it'll have an orange flashing light that will blink rapidly to display that it's in bind mode. Then on your receiver, or on your transmitter, you might typically have a switch to flip, and in your transmitter booklet, you can find which switch this is. It usually doesn't have like different positions. It'll be like a spring-loaded switch. So you'll hold that and then power on the transmitter, and that'll bind it to the receiver. It's a very simple process. It's virtually 4 steps. However, it can get difficult if you don't know what you're doing. Yeah. So now we're going to go through how to set up a vehicle, the actual example of it on Levi's computer. Also, to note, Levi took this picture from a quadcopter. So that's pretty cool. Yeah, here at Corvallis. So it's pretty neat. I can go right here.
So basically what we're going to do is take this little 250 and walk through the actual full setup.
So usually your flight controller will have a micro USB port, which you'll connect over USB to your computer, which you downloaded the software on. Typically the software will be referred to as like your ground station or ground control.
Do you want to just go straight through and assume everybody can find the driver?
So yeah, as we said, we're using OpenPilot, and this is your ground control station.
Okay, first thing I will show you guys before we get started, because I mostly want to do this because I've got this mostly tuned, is the export settings and import. So like if you have a quad tuned and you want to save how you program it, export your settings, and that way you can mess around and not be getting rid of anything you already worked on earlier. So Just gonna get rid of what I got real quick.
So this is good. I mean, if you're doing multiple of the same quad or something like that,
Yeah.
that's a good way of.
So this way, if we mess up anything right now, I can reload what I have. And then, okay. So the vehicle setup wizard basically guides you through everything we talked about earlier, and then you can go back and manually adjust it. Let's see. First thing, of course, always want to make sure your props are off.
Yep.
Actually, we're gonna need a battery.
Yeah. So make sure a lot of this you'll have to do kind of things like calibrating ESCs, moving the throttle up on the receiver. So you want to make sure that your props are off in case something, even though there might be only a small chance it happens, does happen, and your props spin up and they're spinning at over 2,000 RPM. You don't want that to happen. You think?
Sorry, I guess I'm over here. All right. So now we're just gonna update all the firmware, I believe.
So right now you can connect to it over USB and it powers the flight controller itself, but not the ESCs. Is that correct, Levi?
Yes.
Okay.
Let me see, it's not like recognizing it, so.
That noise is the ESCs getting power.
Okay, I'm gonna upgrade just because it's not recognizing.
So what did you just do right now, Levi?
That was upgrading the firmware, or just like basically reinstalling whatever is on there.
Okay.
Yeah. I don't know if it's this cable or not, but it's not recognizing this.
What are you looking for if it recognizes it?
The connection device right now, basically what we're doing is selecting the USB to connect to the flight controller, which is kind of running into a problem now.
Yeah, so typically when you're going through this, it's not going to be a first-time solution. You're probably going to run into a lot of problems, just because that's how electronics work. There are problems, and you'll come to find that out. However, yeah, I would suggest getting an early start and using your resources. So using tutorials kind of like this, online tutorials, coming into the Robotics Club at different points, and we all have knowledge of this stuff. So if you're not able to connect to OpenPilot, like come in or try to look up troubleshoot online. Do you think you're going to be able to connect to it?
It's USB copper control.
Let's see if this one works. If this one works, then
It says copper control, pilot copper 3D.
okay. Yeah, I don't know what to do.
It's not. If you press next, it's not going to go for it.
Okay. That's weird. Okay. Yeah. So yeah, here we select the PPM, PWM. I'm not sure what S-Bus and DSM. Haven't really messed around with
So
that
if you
at all.
look down here, we have a PPM encoder right here. So it takes in all of the PWM signals, which is the multiple lines, and turns it into one PPM signal. So that's this single signal going into the Pixhawk. However, so if you had all of these wires going into your flight controller, you'd select PWM. If you have this single wire going into your flight controller, you'd select PPM, and then you go from there.
All right. Next, obviously, multi-rotor. Okay. And go through here, show you guys different options. little more fun stuff.
And make sure you get the motor number right when you're plugging into the flight controller. We've had, on the X8 for example, we had 2 motors switched. So whenever you turn the throttle up, it would just flip over because it's expecting different things. And that took, 15, 30 minutes to figure out. And it was really annoying because it's like, why is the quadcopter flipping over every single time?
Flipping is always an indicator of the wrong motor.
Yep.
And then, of course, this frequency again. I'm not sure why they have the 50. I'm assuming that's for other applications, not multi-rotor. But always 490 for ours. And then, of course. Okay, now our sensor calibration. This part, I think we're going to calibrate our gyros.
So with calibrating the gyros, you don't need to do anything, right?
I'm going to see if it's telling us to do anything. But yeah, it might be just leveling. Yeah, okay, yeah. So that one basically, we just, told it how level it is and its orientation.
So make sure when you're calibrating gyros that you're on a flat surface, that your quadcopter is not leaning against the computer or something on a weird angle.
Okay, so this is where the more fun stuff starts. Okay, walk through safety procedures. Okay, I've removed all propellers. Vehicle's not powered. Okay. So basically now this is going to be like a whole flight controller ESC calibration all in one. Gonna walk us through.
So what we're doing right now, if you guys came to the workshop, I think it was last week, is where we manually calibrate ESCs. This is kind of doing it for you with steps along the way. So the same process goes, you turn the throttle to high, then you plug in the battery.
Are we on high already?
Yeah,
Okay, I'm plugging in the battery.
for it to be and then press stop.
Okay. Alright, now this is that one screen I was talking about with the dials earlier where they're very low to show where the motor starts to spin up. Try to move this faster so you guys can see it. Got a very short cable, but basically we're going to bring the dial up until the motors start to spin. Let's see. You want to just do that actually?
Yep. We need to press start.
Oh, okay. That's good.
So then bring it down.
No, that's perfect.
Okay. And then press stop.
Yeah.
Okay.
And do for the next one.
All right. So what is this doing?
Basically telling the flight controller where the very minimum is for the ESC.
Okay.
So this is where it just begins to spin. That's going to be minimum throttle, I guess, or
So if you do this with an X8, you have to do it with all 8 propellers. Nice. More or less.
That's why having the configuration page is helpful, because you could just go through and set them all.
Gotcha. Okay. So can you do this under the configuration page?
Yes.
Okay. All right.
All right. Next. All right. This part I usually don't use much, but you can, if you have a quad that you based off of somebody else's build, and it happens to be in their database, then you can actually pick their settings. So, or just find something very similar to your setup.
Yeah.
I have no clue which ones of these would be similar to mine, so
Generic X.
let's go with that guy. Okay. And saving it to the flight controller.
Alright. So then, in other tuning, you go through like accelerometer, compass, and stuff like that.
Yeah.
Okay.
Assuming we didn't have to use no GPS.
Alright.
Okay, so now we're going to go through setting up our transmitter. Okay, and that's what I was talking about earlier. It's always going to set you to disarmed. Okay. Do you mind walking through this part actually while I plug this in? Because I gotta.
Okay. Please choose your transmitter type. Yep, you just kind of follow the steps through. So for mode to choose, I remember talking about this week 1 when we were talking about the modes of flight. You probably want to use mode 2 for your transmitter always. That's left stick is throttle up, yaw left and right, and then the right stick is pitch forward, pitch backwards, roll right, roll left. The other modes flip that and are not consistent throughout other quadcopters, so make sure you're on mode 2. And then we need the flight control, transmitter now.
Plugging our cables in real quick.
Yeah. So what you're going to do here is just tell the flight controller what the high points and low points that the transmitter gives, just so it knows when you arm it to not spin up the motors to a very high position. And it also knows that when you're going left, you want to go left. You don't want to go in the middle or right. So it gives you just the center points, virtually.
Essentially right. Ready? Okay, so I've just got the receiver plugged in. I'm going to see if this receives anything. Okay, moving the roll stick, pitch stick. Yeah.
So if you go up and down with this one, that's throttle stick. Right and left, that's roll. Up and down is pitch. Left and right is yaw. And if you remember those are the ones that are correlated to the receiver 1, 2, 3, 4 inputs. And then you can set all of the channels as well here, which, I mean, the Turnigy had 24 channels, so it'll have 24 switches that you can fiddle around with, so it can get out of hand.
And at this point, it's trying to get me to set more switches, but I've only got one, so we're just going to skip and be done with that part. And, okay. I'm actually going to skip through most of this because I'm going to come back through it after we do the initial setup. Okay, so basically this is just what we walked through earlier. We're going to set up our RC input. Got PWM for everything. Throttle, I believe, was 3. Yep. Pitch was 1, do you know?
Yep.
Okay.
And then yaw is 4.
This is why sometimes just skipping the setup for certain parts is actually helpful. So you're just going to end up having to change everything anyways. Okay. Let's see if it reads us. Okay. So it's recognizing at least one switch, so I'm going to try calibration and see what it does. And basically now that's calibrating, we're just moving our sticks everywhere around as far as we can, every point or whatever. Okay.
And that's just moving sticks to the bottom left, bottom right, top right, just giving the maximum values.
So now I've got everything moving. I'm going to stop the calibration because at this point this is where you check all your receiver and transmitter settings, because I don't know if we'll want to waste too much time on this afterwards, but like right now I've obviously got something mixed up because if I push my throttle up, that's moving the yaw. So I don't know if you guys noticed that. So we obviously have to do some switching around and get everything, the wires adjusted. But that's the basic setup for the transmitter at this point. And then if you start to try to take anything off the ground and find it's backwards, your reverse button's right here to make things simple for you. And I think we don't have power here. Something's dying.
Yeah.
So.
All right, so that's mainly it. The last note on reversing things, make sure when you're on the ground before you fly up in space, you can quit out of this, Levi.
Okay.
Before you fly up, make sure that you test on when you're on the ground, rolling right, rolling left,
I stopped.
pitching backwards, pitching forwards. Because if it's backwards and you fly up and you start to go everywhere and the controls are not right, you might get really screwed up. I ran into a tree recently doing that, so yeah, that's that. So thank you guys for coming. Next week we're probably going to go into the accelerometer tuning, compass tuning, and PID, other things like that, and then the last week we'll probably go into assembly and finish up any tidbits we haven't covered so far. So thanks for coming, guys. We appreciate it, and we'll see you next week.
Rock on.
Yeah. Definitely reversing sticks is